one of the basic things that we should be understanding is sample space. Just me quickly recall the definition. Like sample space is nothing but when you're discussing some probability theory, it's mostly we're talking about some random events, right? So we don't know, we are doing some experiment whose outcome is unknown for us, right? So for example, if you're throwing a coin toss, so the outcomes, it might either land on a head or a tail, so we are not sure what the outcome is going to be. So sample space is just the collection of all the outcomes that are possible, right?
Okay.
Set of all possible outcomes of our experiment.
Hmm.
So one of these things will happen as the output of the experiment. So we are throwing the coin, and either this or this will happen. So when we collect all of them into a set, then it's called the sample space. So on top of this, we'll define probability, right? So for every element in the sample space, so this is called element in the sample space. For every element in the sample space, the probability will assign some number between 0 and 1. So, so for every element, it will assign some number. For example, if it's a fair coin, it would have been like this. So we should assign some numbers, and they should sum to 1.
Right.
So this is called probability. For like there will be two kinds of sample spaces, discrete and continuous. So for example, this was a discrete sample space, right? When I mean discrete, it's like we can count the number of different outcomes that are possible, right? For example, if you're throwing a dice, the outcome will be 1, 2, 3, 4, 5, 6, right? If it's a six-faced die, so it's a discrete experiment. For example, if you are looking at something like any real number between 0 and 1, if you're asking for any real number between 0 and 1, then there are infinite possibilities, right? It can be 0.99, it can be 0.76432. So there are infinite possibilities, so it's a continuum of possibilities, so it's like continuous random variable. It's a continuous state space, sample space. So am I going into too much basics? If
No, no,
you feel,
we can understand. You're perfect. Yes.
in case you feel it's like too much redundant, I can skip through some parts. Let me know if you feel it's too big.
Okay.
So this is clear, right? This part. So it's discrete and continuous. So for example, here in this part, there were only two possibilities. So we were able to assign probabilities like this. For example, in the continuous case, do you think it is possible to assign values for each number?
No,
Why? Don't think so.
it's continuous, right?
So even though it's continuous, for every point there is some chance of happening, right? So we need to come up with some way to assign that probability.
Okay.
So here we do it using something called PMF. So for discrete thing, we call it probability mass function,
Mm-hmm.
because for every value we are assigning some particular number.
Right.
But here we cannot assign like that, as you said, like it's tough to assign for every number. For 0.99, if you assign something, for 0.991 we have to assign some other number.
Yes.
So assigning for each number is difficult, and intuitively also we can see that for a given particular number the probability is almost zero, right?
True.
Because there are so many things, infinite possibilities are there. So people have come up with something called PDF, which is like probability density function, where instead of assigning for each value, we'll assign probabilities for each small range. So we
Right.
talk about the probability of some, let's say if this is some number h, we'll discuss things like probability that h is between let's say 0.1 to 0.2. So we can talk about probabilities of this kind. So talking
Right.
about these kind of probabilities doesn't give us much, because it's for everything we'll have to assign almost zero probability.
Right.
So this is so assigning these kind of things will be happening through something called PDF.
Okay.
Okay, and then so this is about sample space and kinds of sample spaces.
Yeah.
Now there is next step. There is something called event.
Okay.
So a event is defined as any subset of our sample space is called an event.
Mm-hmm.
For example, let's say we are throwing a coin pair die, like with the six spaces. So the sample space is this, right?
Right.
So a event is we may not be very much in some of the times. Let's say we may not be interested in actual outcomes. We might be interested in some set of events. For example, the sample space was the marks obtained by one student. Let's say so the sample space would have been 1, 2, 3, so on and 100, right? So for the mock, if it was a mocks for 100 mock exam, so the marks obtained by the particular student would have been 1 to 100, all the possibilities. So
Right.
most of the times we won't be interested in the exact outcome of that student, but we'll be interested in whether the student has passed, whether the student got A grade or B grade or C grade.
Right.
So we'll be interested in some specific uh, outcome rather than exactly get looking at one of these outcomes. For example, we might be interested in whether the if H is the student marks, whether H is greater than 35 or not.
Mm-hmm.
So that means we are asking exactly what we are asking, whether the outcome is in this set 1, 2, 3, so on 35, right?
Right.
So we are asking, we have done some random experiment and we are asking whether the outcome is within this particular subset of the sample space. So this was your whole sample space and you are asking whether the outcome is in this subset of the sample space.
Mm.
You understand, right? This is a subset of the sample space. Oh my god, this was a sample space and this is a subset of it. So a event is defined as any subset of sample space.
Mm-hmm.
So here E is a subset of sample space, right?
Right.
So events are some meaningful subsets like this, like whether a student is passed or not. So these kind of subsets we can define as events.
Mm.
So for this sample space, can you tell me one event which is slightly meaningful for the for the die experiment?
Set
Yeah,
of 4 and 5.
yeah. Or that is one example, or whether the die turned up into an even number. That is one such event, right?
Mm.
So A is like set of 4 comma 5 is one event, as I said. Or there can be multiple events that we can define, right? If it was 1, 3, 5, it would have been whether it's an odd or not. That's
True.
what we're asking.
True.
So, so when you are looking at events, so a lot of times we'll be interested in some combination of events. For example, here we'll also be not just be interested. One thing is we will be interested in finding the probability of event occurring. So for that, it's trivial. You just sum over all the probabilities of the elements in that subset. So,
Oh,
So it would have been, if it was every phase was equally likely, it would have been 1 by 6, 1 by 6 like that, right?
Mhm.
So it would have been 2 by 6, like 1 by 6 plus 1 by 6.
Yeah.
So this is how you calculate probabilities for events. You just sum over, you just look at the subset and add those probabilities. So then there'll be, sometimes we'll be interested in some combination of these events. For example, A union B or A intersection B, like this.
Right.
So during that time, let's say you're playing some game like this, and you will be winning the game if you either land in one, or if you land in some even number. So so A union B is like A or B. Either A should occur or B should occur, right?
Right.
So for example, if this was your A and this was your B, so what do you think probability of A union B will be?
5 by 6.
Why do you think so?
You're adding, right?
No, where did we do that? We did not define that right here. Like I just told, if you want to get a probability of one event, you have to add all the possible elements in that which will give this outcome. For example, A will occur if 4 or 5 will occur. So you are adding those two, right?
Mm-hmm.
So now you are asking what is the probability that A or B occurs. That means you are asking what is the probability that, let's call this A union B as C. Okay. So what are all the possible outcomes that for C? 1 is fine. 3 is also fine, right? 3,
Okay.
4, 5. That's all right.
Okay.
So it would have been what? So the probability of occurring A or B will be what?
Okay.
That is
4 by.
probability of C equal to, it will be 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, right?
Mm-hmm. Okay, 4 by 6.
Yeah. So, so what did you understand from this? Probability of A union B is not probability of A plus probability of B, right? Because
Okay.
it would have been 5 by 6 if this was true.
Mm-hmm.
So what was missing here? We might be over counting sometimes, because there was some, B was also counting the occurrence of 5, A was also counting the occurrence of 5, right? So A is also counting 5 and B was also counting 5. So there totally one extra count was coming here. So to rectify that, we just need to do this. So you add the probability of A, add the probability of B, just subtract what was counted twice. So A intersection B means it was counted both in A and B.
Right.
So what was counted both in A and B? 5 was counted both in A and B, right?
Right.
So you would have, if you wanted to use this formula, you would have done like this. Like as you said, it would have been 2 by 5 here. This was 3 by 5, right? Probability of B was 3 by 5, right? A was 2 by 5. B was 3 by 5. And what is A intersection B? A intersection B was 5 was the only intersection for them,
Mm-hmm.
right? So you would have subtracted probability of 5 because that was A intersection B, right? So it would have been 2 by 5 plus 3 by 5. Sorry, 2 by 6, right?
6 is
Right?
the sample space, right?
Yeah. So it's like you were asking what is the probability of
2 by 5, yeah. This is 3 by 5, yes.
2 by 6 and 3 by 6, right?
Yes, 3 by 6. So it should be 1 by 3 plus 2 by.
Yeah. 2 by 6, 3 by 6. Because it's like 1 by 6 plus 1 by 6 plus 1 by 6. So it would have been 2 by 6 plus 3 by 6 minus what is probability of 5?
1 by.
1 by 6, right? That's, you're fine with this, right?
Mm-hmm.
So probability of
Yes.
5 is 1 by 6, right? Because it's 1 out of the 6 probability. So it would have been 4 by 6, right? Like 2 plus 3 minus 1 by 6. So is this part clear?
Mm-hmm.
Fine. So whenever you are talking about OR or union, it's just like addition, but with just careful subtraction of the joint term. Like whatever was being counted twice, you have to subtract it.
Hmm.
So you can remember union as just addition with careful subtraction, right?
Right.
So then let's go to intersection. Like intersection is one more thing. Like you understand, this was a union formula, right?
Mm-hmm.
So here intersection also we should be slightly careful. For example, let's try this problem. A is I'll define A as the event where A means some odd number has occurred. Okay, that means you understood, right? It would, the outcome would have been 1, 3 or 5. Fine.
Okay.
So now I'll define B as the set of events where mm, okay, B I'll define as 4. The set of events
Sure.
Got
B
it.
means I'm defining it as 4. If the die turns out to be 4, then I will call it as event B. If the die turns out into 1, 3 or 5, I will call it as A.
Yeah, we are with you. Yes.
Okay. So now what do you think the probability of A and B occurring, both of them occurring together? Like probability of A and B means what does that mean? We are asking that both A and B should occur.
Hmm. Yeah.
You understood what is and, right? And means A and B should occur.
Right.
So can you guess this answer? So first of all, what is probability of A here?
1, 3, and 5.
Yeah. So what should be the probability of A?
3 by 6.
Yes. 3 by 6 should be 1 by 2.
Yeah, 3 by 6. And probability of B is,
Probability of B 1 by 6.
yes. So now what is that you are asking? You are asking that A and B should occur at the same time.
At the same time.
Yeah. So
We need to add it.
it will be technically 0, right? Because if odd number
Yeah,
4
yeah.
will occur,
Mm-hmm. 2.
right?
Hmm?
So then,
Can you repeat it again? He didn't
We have lost your
understand.
voice for a minute.
okay. So what is and means, like the outcome should, both is event should happen.
Right.
So there is no possibility that both of them will happen at the same time, right? Like if the odd number occurred, there is no chance that 4 will happen.
Right.
Yeah, so the probability is
I think I'm not able to hear you, right? Okay, can you
uh,
hear me now?
yeah,
Yeah,
yeah.
we can hear you. We can
Okay,
hear you, but we are a bit confused. Like,
You've lost your voice for a
okay,
minute. Now it is fine.
how? Now we can hear you. Yes.
right?
Yes.
Why 0 has come here? Okay, let me take another example and maybe explain you in a bit more detail about intersection. Let's say you have a coin toss experiment. Okay, so you are throwing a coin and it can either land in head or tail. So these are the two possible outcomes. Okay, and let's say the experiment is I will toss the coin 2 times. I will toss 2 times. Okay. So now, what do you think the sample space will be for this experiment?
How will it be 2? The probability has to be 1.
Sample space.
So, sample space is what? Sample space is the set of all possible outcomes, right?
Right.
Yeah, that is 1 by 2 and 1 by 2.
No, it's not probability. Sample space is what is sample space?
It's 2.
It is 2, but the probability I'm saying that is equal to 1 again, right?
No, let's not go into probability at this point. Like, what is sample space means it's the set of all possible outcomes, right?
Okay, that is 2.
No, it's not two, right? You're tossing the coin 2 times. So,
4.
what are the possible outcomes?
That is 4.
How many possible outcomes are 4? What are they?
Could be anything.
Head, tail,
Like
head.
head is one possibility,
Yeah, head,
head tail is one possibility, tail
tail.
head is one possibility, and tail is one possibility.
Yeah.
So, like while it's very intuitive, but it's good to go in a systematic way because it will help us do some calculations clearly. Because when you write this set, lot of things will become clearer. That's why I'm just making it more rigorous here. Fine. So you understand that this is the sample space, right?
Okay.
So now is the question of probabilities. Like let's say it's a fair coin, then there is equal chance for head and tail, right? So now so this probability would have been 1/4. So all are equally like late. There is no bias for any of these things. Any of these four would have occurred with equal chance. Like there are 4 different possible outcomes, and anything would have happened with equal chance, right? There was no bias in the coin.
True.
So intuitively, it would have been 1/4, 1/4, 1/4 because there are 4 possibilities, and there is no favor for any of these outcomes. All are equally possible because the coin was fair coin. So it would have been 1/4, 1/4, 1/4, 1/4, right?
Yes.
So now let me define one event here. My event A is that 2 heads have occurred. Okay. So this is my event A. So what will be the subset corresponding to this?
2 heads.
Heads, like this, right?
Yeah.
Right.
And another event is, let's say, uh, at least one head has occurred. At least one head. So what do you think is the sample space for this? Sorry, the event subset for this.
Head, tail, and tail and head.
Yeah. So now let's do some calculations with these 2 events. Now if I ask probability of A or B, how will you approach this?
Say it again.
So if I have to calculate probability of A or B,
Okay.
so what do you think? For this, the answer is what? 1/4, right?
1/4.
Probability. For this, it will be 3 by
3.
4. Probability of A or B will be what?
3/4 minus
Yeah.
1/4.
Uh,
Is it?
How did you come up with this? Like 3 by 4 is what?
3 by 4 is the possibility of B
Okay, probability of B.
minus probability of A. I think so.
But that's not how we define, right?
Okay.
So what we define we discussed that OR means addition, except that you have to subtract common things, right? So we
Yeah.
have defined that to be probability of A plus probability of B,
Minus
probability of
probability of A and
A.
B. Ah, right.
So it would have been what? 1
3 by
by
4 plus
4.
1 by 4, 4 by 4 minus 1 by 4.
Why it's 1 by 4? Because the intersection is only this, right? A intersection B means this HH is
Yeah,
the common. So probability of HH is like 1 by 4. So it would have been 3 by 4.
by 4.
Yeah. So or you are clear, right? Now let's look at AND more clearly. The probability of head, if I define event A as like this, let's say uh, event A is head in first toss. Okay. Event B is head in third. Tail in second toss. Like we are doing it 2 times, right? First time you should get head, and second time you should get tail, right?
Okay.
So since it was when you ask something about only first toss, you could have just dealt with this sample space, right? HT. Like first thing could have been 2 things. 2 things are possible, right? In the first toss, head or tail. So both are equally likely, right? This part is clear, right?
Yes.
So similarly, probability of B tail in second toss would have been like this only, right? So in the second time also both are possible, and you are asking to tail. So this is clear, right? Probability of B will also be half.
Half, yeah.
But if I ask probability of A and B, that is head in first toss and tail in second toss. So if I ask like this, can you use these two and answer me to compute this? These two values can we use and compute this? Can you come up with, like we came up with some formula for A or B, right? It would like
Yeah.
A plus B
Yeah,
minus
that's
C
what I was about
intersection
to
B.
say. Can we use the same thing here?
No, we have to come up with some formula like that for A and B also. So can you guess anything? Like we know that this is 1 by 4, right? Because we already saw that. Like what were we asking? Head in first toss and tail in second toss, right?
Yeah. Yeah, that is 1 by 4.
So we know it's 1 by 4. Can we formally come up with a formula? Is what I'm asking. Like we understood, like R is like addition, like roughly like addition, except that you have to subtract if there is anything common.
So there is nothing common. So it is 1 plus 2 and 1 plus
No,
2, right?
but that was for OR. This is for AND. That means you are asking both of them should happen,
Yeah, but there
right?
is nothing common to subtract, right?
Yeah, true, true. No, it is not OR. This is for AND. For AND, what we are asking is both should occur. So both should occur means we should multiply those probabilities, because if there is 50% chance of occurring something, and another event also is 50%, so you should multiply them to get the total probability, actual probability, because for getting first toss head there is half chance, and for getting second toss head also there is half chance. So what is the total chance will be like multiplication of half into half, that
Okay.
will be 1 by 4. So this is how AND will work. Addition, OR means you have to add, AND means you have to multiply. That's what I'm trying to tell you.
Okay.
Like OR is roughly like addition, AND is roughly like multiplication.
Okay.
But the careful thing is when you are ORing, you should not simply blindly add. You should just subtract what is there in common. That is one thing. So for AND also there is some care that we should take. Right now we just multiplied them and it turned out to be right. Correct?
Mm-hmm.
So let me give one more scenario where AND blindly multiplying them will fail. We need to just be a bit more careful. For example, if you are looking at die experiment, where sample space is like 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6. So let me define A as odd, okay, B as 4, as we took previously. Now, what is probability of A and B? Like probability of A is what? It is like 3 by 6, right?
Yeah.
Probability of B is like 1 by 6. So, but what is probability of A and B? If you just multiply them, it would have been 3 by 6 into 1 by 6. It would have been 3 by 36 or something, right?
Mm.
But intuitively, we know that it's 0, right? Because we want both odd number and 4 at the same time.
Yeah.
So it's 0. So we should not blindly multiply them, right? So what we need to do is, there is something called conditioning. We need to use that. So what is conditioning is, let's say I tell you that odd number has occurred already. Like it's like some part of the outcome. For example, someone has tossed a die, and he knows that odd number has come, but he does not exactly know what number has come. He just knows that odd number has come, right? Is the setting clear? Hello, Ram. Is the setting clear?
Right.
Yeah, we can hear you.
No, you understood what the conditioning is. Like he just knows that odd number has come, but he does not exactly know what number has come. He just
Okay.
knows that it's an odd number, but he does not exactly know whether it was 1, 3, or 5.
Okay.
So like that, so probability of 1 is 1 by 6. We know this already. But a new thing is probability of 1 given that it's an odd. This is what is called conditioning. Like here we don't know anything. We are just asking what is the chance of 1. It's 1 by 6. That we know already. But now someone is telling that the odd number has occurred already. But he does not know which number has occurred. So now we are asking, given that odd number has only come, what is the chance that 1 would have come? So what do you think this would have been? It will be 1 by 3 if you logically think. Because someone is telling that odd number has come.
Yeah, there is only 3 possibilities.
So there are only 3 possibilities. So knowing that odd has come, what is the chance of 1 means it's 1 by 3. But if you don't know anything, what is the chance of 1 means it's 1 by 6. This part is clear.
Yes.
So this is what is called conditioning. So we need to use that conditioning to define AND correctly. Okay. So probability of A and B is defined like this. So it's like probability of A into probability of B given A. Fine. Is this part clear?
Okay.
So now what is the, like, now let's test whether this 0 will come with this formula or not. Like if we blindly use AND, it was giving multiplication, it was giving wrong value, right? It was supposed to be 0, but we got 3 by 36 when you use this formula. But I'm telling that if you make this correction to this formula, you'll get the right answer. Now let's see what will happen. Like what is probability of A? It's the probability that odd number has come, right?
Yeah.
So that is 3 by 6, right?
Mm-hmm.
And what is B given A? That is probability of 4
by 3.
given odd, right? A is odd, B is 4. So this is what we are asking. So it would have been 3 by 6 into, what is this value?
1 by 3.
0, right?
Yeah, 0.
Because
Would
you
not
know
be-
that it's an odd number,
Yeah.
but you are asking still what
Would
is the
be
chance
odd.
that 4 has? So it's 0. Fine.
Right.
So these are the two things mainly. Like what all you learned is like what. So let's summarize the concepts that we learned today. The sample space was set of all outcomes. Event is like some subset of the event is like subset of
Sample space.
sample space. And any event. Okay. Then what we learned? We learned about combinations of events. A and B we learned. A and B is like both of them should occur. That is probability of A intersection B equal to probability of A into B given A. This is one thing we learned. Then what did we learn? A or B. Probability of A union B is just summing them and subtracting the common thing, right? And we also learned conditioning. A given B means probability of occurrence of A given B occurred already. Given B occurred already, right?